In section 9.4 we are studying volume, and so here we're looking at various volumes of various shapes like rectangular solids, the volume of a cylinder, circular cylinder, and the volume of a sphere, and then given the radius and the height, find the volume of a circular cone. We're talking about that. So, and then we solve some applied problems involving rectangular solids, circular cylinders, spheres, and cones. At the most basic level, the volume of a rectangular solid is the number of unit cubes needed to fill it. So you see one unit cube. It could be 1 cubic centimeter, 1 cubic inch, but it's a unit cube. And so as we fill up the layers, we notice there are 9 each on each layer. That's for a total volume of 18 unit volumes, unit cubes. And so here we're looking at 2 unit cubes that are used to measure volume. One, of course, would be 1 cubic inch. It's a cube that has 3 sides, and all 3 sides have the same length of 1 inch. And so there would be 1 cubic inch, or inch to the 3rd power. Similarly, for a unit 1 centimeter long, 1 centimeter high, 1 centimeter deep, we have 1 cubic centimeter, and it's also used or written as cm to the 3rd power, centimeter to the 3rd power. In exercise 1, we are supposed to find the volume, and we know, excuse me, we notice we have as a unit cube 1 cubic centimeter, and so we count how many units there are: 1, 2, 3, 4, 5, 6, and we have 2 layers of 6. So 2 times 6, 2 times 6 cubic centimeters is equal to 12 cubic centimeters. Given the rectangular solid with length and width and height, the volume of a rectangular solid is found by multiplying the length times the width times the height, L times W times H. It's a very simple formula. So let's look at a piece of luggage here, and we look at this as a rectangular solid. And so we have length times width times height. So the length is 23, the width is 10, and the height is 13. So we simply take the product, the volume, we take the product of length times width, 23 times 10 times 13. So that's equal so that's equal to 2,990 cubic inches. Similarly, exercise number 3, a cord of wood. A cord of wood measures typically 4 by 4 by 8 feet. So again, we use the volume, length times width times height. So the volume is equal to 8 times 4 times 4, which is equal to 128 cubic feet. Next, we'll be considering cylinders. And like rectangular solids, circular cylinders have bases of equal area that lie in parallel planes. The bases of circular cylinders are circular regions. And so the volume of a circular cylinder is simply base times height. And since the base is a circle, the base is equal to pi times r squared, the radius squared, times the height. Again, notice that the base is a circle, and so the base is equal to pi times r squared. And then we multiply by the height. So let's look at an example. Number 4, find the volume of a cylinder, and we're supposed to use 3.14 for pi. So the volume is equal to pi times r squared times h times the height. And so since the radius is 5 feet and the height is 10 feet, we have 3.14 for pi, and then r squared is 5 times 5, for the radius is 5, times the height, which is 10 feet. And since 5 times 5 is 25, and 25 times 10 is 250, and we multiply that by 3.14, and we get 785 cubic feet. So when it's volume, it's always some quantity like feet raised to the third power. Length would be feet, area would be square feet, and now we talk about volume, it is cubic feet. And number 5 is very similar. Find the volume of the cylinder. So the volume is equal to pi times r squared times the height. So 22 divided by 7 times the radius of 21. So times 21 times 21. And the height is 49. So that's the 7 cancels against the 21. It gives us a 3. So it will be 22 times 7 against 21 is 3 times 3 times 21 times 49. That's cubic meters, and that's equal to 67,914. 67,914 cubic meters. Next, we'll be talking about spheres. And the sphere is a three-dimensional counterpart of a circle, and is defined as a set of all points in space that are a given distance, the radius, from a given point, the center. So the center is here, and the sphere represents all the points that a radius can have. And now for the formula, for the volume of the sphere, is given by 4/3 times pi times r to the third power. Very simple formula, 4/3 pi times r to the third power. And let's jump into the guided solution here. Find the volume of the sphere and use 22 divided by 7 for pi. So 4/3 pi times r to the third is about 4/3 times 22 divided by 7, that's for pi, times 28 feet to the third power. And 28 feet to the third power is 21,952 cubic feet. And now we multiply 4 times 22 divided by 7 times 21,952, all divided by 3, and that is 91,989 and 1/3 cubic feet. Okay, here's another example. The radius of a standard size golf ball is 2.1 centimeter. Find its volume. Use 3.14 for pi. So here we have V, the formula for the volume of a sphere, 4/3 pi, and pi is 3.14. Times 2.1 centimeters to the third power, since the radius is 2.1 centimeters. So it's equal to 4/3 times 3.14 so that's times 9.261 cubic centimeters. If we multiply 4/3 times 3.14 times 9.261, we get 38.772 cubic centimeters. Next, we talk about cones. Of course, everyone is familiar with cones because there's hardly any child who didn't have an ice cream cone when they were little, and perhaps even as adults. So, in mathematical terms, consider a circle in a plane, this one or this one here, and any point P that's not in the plane. The circular region, together with a set of all segments connecting P to a point on the circle, is called a circular cone. And then the height of the cone is measured perpendicular to the base. So sometimes the height will be inside the cone, or it could even be outside the cone. It doesn't matter. So the volume of a circular cone is given as V equals 1/3 base times height, or 1/3 pi r squared. Remember, the base is a circle, so this part here is the area of a circle times its height. Okay, very simple calculation. So let's apply that to this next example. So the volume of this cone here with radius 9 meters at the base and a height of 20 meters. So in other words, R is equal to 9 meters. H is equal to 20 meters. And the volume is equal to 1/3 times pi times r squared times h. So in other words, it's equal to 1/3 times 3.14, that's for pi, times r squared, and so that's 9 times 9, times the height of 20, times 20 cubic meters. And so when we calculate this number, it is equal to 1,695.6 cubic meters. Similarly, for number 9, find the volume of this cone. Here we're using 22 divided by 7 for pi. Again, the volume of a circular cone is equal to 1/3 pi times r squared times h. So here r is equal to 6 inches and h is equal to 14 inches. So then the volume is 1/3 times 22 divided by 7 times 6 times 6 times 14. So we notice that the 7 cancels against the 14, gives us a 2. So therefore, the volume is equal to 528 cubic inches. So in number 10, we look at a medicine capsule, and so that cold capsule is 8 millimeter long and 4 millimeters in diameter. Find the volume of the capsule. Use 3.14 for pi. Here's also a hint. First, find the length of the cylindrical section. Okay, let's make a sketch of what this looks like. So here's the cold capsule, 8 millimeters long and 4 millimeters diameter. In other words, the radius is 2 millimeter, and when we subtract 2 millimeters of radius at this end and at that end, we have to subtract 4 millimeters from 8 millimeters, so the midsection, the cylindrical section, is 4 millimeters high. That's why we have 4 millimeters height for this cylinder here. The sphere has radius of 2 millimeters, and so now we can compute the volume of this cold capsule. It consists of the volume of the sphere. 2 half spheres make one sphere together, and the volume of the cylinder. So let's do the volume of the sphere. 4/3 pi times r to the third, and that's 4/3 times 3.14 times 2 millimeters to the third power, and so that is equal to 33.49, approximately rounded up to 2 decimals, cubic millimeters. So that's for the sphere. That's why I use the subscript of S. Now the volume for the cylinder is base times height, so it's pi r squared times h. And since we use 3.14 for pi, 3.14, and since the radius is 2 millimeters, it's 2 times 2 times the height, and the height is 4 millimeters. So millimeter times milliliters times milliliter is millimeter to the third power. And when we multiply this out, we get 50.24, 50.24. Okay, so that's the volume for the cylinder, cubic millimeters. And this is the volume of the spherical part. So then the total volume is the volume of the sphere and the volume of the cylinder. In other words, it's equal to 33.49 plus 50.29. That's equal to 83.73. 83.73 cubic millimeters. So, as a little challenge, see if you can do it. So again, the volume of the sphere was 33.49 cubic millimeters, that's rounded. And the volume of the cylinder, the mid-sectional, is 50.29 cubic millimeters. And then the total volume is the volume of the spherical parts and the cylinder in the middle. So it's 33.49 plus 50.29 equals 83.73 cubic millimeters. And this is the end of section 9.4.